What's up, guys? Today we're going to go over configuring a database in Django. So, what is a database? A database is basically just a software designed for storing collections of data and long-term storage and providing a means to query and manipulate that data. So the common operations you're going to be performing on a database is going to be querying, which is basically the ability to search based on certain criteria. Creation of new data, deletion of new data, updating, so basically just changing the values of certain data. And this is one a lot of people don't immediately anticipate: aggregation operations on certain data. So you might want to be able to say, look up let's say how much everybody has spent on a certain item inside of your database, and sum that all up to see the total amount spent on it or something like that. So there are two predominant paradigms. There are two ways we section off databases currently in industry today. There's relational databases and non-relational. So for a long time, basically the only databases people were using were relational databases. These databases, they excel at performing sort of different operations, like defining how data links to one another and searching through data in really interesting ways where you could look up data based on relations of each other. More recently, basically in the advent of big data, people have started using other types of databases that we just refer to as non-relational databases. These databases usually store things in these JSON-like objects. This includes stuff like MongoDB, and they excel at what they do is they give up the ability to form more complicated associations between data, and what they gain in terms of that is certain amount of performance. So they give you these databases generally excel at being able to pull stuff really fast from your database. So for this course, though, let's forget about that. We'll only be using relational databases. So what do I mean by relational? So you any of these SQL databases that you heard before, these are all relational databases. A relation, I'll give you a bit of a more mathematical definition of it on Friday, but for now, let's just think of a relation as a table. So a table that's going to have columns, which we could call attributes, or also referred to as fields, and rows that are entries into our database. So here's a little example relation that has two attributes or fields, name and age, okay? And the database currently has two entries into it. So somebody entered Curtis is 50 and Chris age 20. So object relational mapping is a technique that takes objects, usually inside OO, and turns them into an SQL table. This allows you to just be like, well, I have this object that I've created and I'm using in my OO program. Let's store it into long-term storage, into the database. So this greatly simplifies the use of a database. And one of the reasons I chose Django for this course is it has built-in automatic ORM. So it'll actually do this for you. It'll automatically take objects that you've defined it in Django in a certain way, and it'll generate the SQL table for you. So we're not actually going to have to use SQL directly inside this course, which is a good thing because I could easily teach a whole course on SQL on its own. So Django models are how we're going to perform automatic ORM. So whenever you create an app, it'll have a models.py file, and what you're going to do is you're going to go into this file and you're going to import this django.db.models package. And this models package will provide you with a model class that you can inherit from and define. It's also going to provide you with different attributes for defining fields. And you can take a class like this and you can use it to generate a corresponding SQL table. So this would be the corresponding SQL table to this model here. If you want to know more about models, you should refer to the documentation here. It'll list the model class that you're inheriting from. It'll show that, and as well as it'll list the different fields that you could be using. So it'll generate. This is the actual SQL code that it'll generate. We can kind of ignore this code inside this course, so we could work entirely from this class here. Okay, so we've been doing this all along, and we've already needed to do this for templates. But just a reminder, if you're going to be using models, okay, models are going to be specific to apps. So you're going to have to create an app. It's going to have a models.py inside it that you put your models in. And then in order to actually use those models, you need to make sure your app is installed. If you don't install your app, the steps I'm about to show you to generate your SQL code from your models is not going to work. So make sure you do this. We've been doing it all along. Just make sure you do it as a reminder. Okay, so here's an example model that you create. Say you create an app, my app. Okay, you'll add this class to my app models.py, and this is a little class that implements the person relation that I showed you before. That I gave a little example of before. This person relation here that has a name and an age attribute. Okay. So to do this, we create a class, we call it whatever we want. It inherits from the model class. And then we'll give it two class attributes, name and age, okay, that use these fields that are also from the models package. One is going to be a char field, so that's how we're going to store strings. And we need to specify the max length of a string here, so 30 characters should be good for a name. And one is going to be an integer field that we use to specify the age. And then you can use this model, let's say in your corresponding apps views.py, by defining a view and importing the models.py and just importing the class. And you can perform operations. I'll go over the different operations you can perform in general, but you could use the attribute dot objects to retrieve all of the entries that have been made into this models table and do whatever you want with them. So to play around with this, let's go to our code here. We could open up so if you go to Django templates, the Django templates repo, which if you don't already have it checked out, you can clone the Django templates GitHub repo. So if you go to this repo, I've defined a project, simple models. So let's cd into that project. Okay, and this project, it has two apps that I've already created for it. So done is going to be the finished product of what we're about to go over for today. Let's work from the start app here. So if we look inside of the start app, let's look inside of the start apps models.py. So in Django templates, simple models, start. Let's look inside of the models.py. Okay, and I've already defined this person models for you. And if you open up the views.py in the same directory, I've already defined this view for you. And if we pay attention to the comment, you could look through the urls.py at the head of the project and in start urls.py to verify this. But this view will be routed to from e/macid/ this should be start /first_person. Okay, so we might be rearing to go and say, okay, let's just run the server and let's try going here and let's see it return a person from our database. One problem though, we haven't actually created our database yet. So what I've actually done here by making this class is I've made kind of a template for making a database. I've kind of defined like how to make the table, but I haven't actually made the SQL database yet. So in order to do that, I'm going to have to get Django to generate it for me. So to do this, I'm going to use Django, and I'm going to use that manage.py file at the head of my project. And I'm going to have to use a couple of different commands, unfortunately. It would be nice if I could just do like Python manage.py, generate me a database. But we want to be able to do some complicated stuff with our database, including like going back to like old versions of it and stuff. So Django complicates this a little bit. So we're going to have a couple of steps here. and we're going to have to keep track of something. I'll go over it in a second. The migration revision number while we're doing it. So let's actually generate our database. So we have this class here that's in my start app. So let's generate the database from this class. Let's generate that table. So make sure we're inside of the same directory as the manage.py. Activate our Django environment so we have access to Django. And let's run Python manage.py make migrations. Okay, and it's gonna make the migrations for each of the apps I got going on here. Ignore the done app. Let's focus on the start app here. And you'll notice that it gives this revision number 0001 when you make the migration, and it created the model person for us. Okay, keep track of this revision number. So this revision number, every time you want to update your table to include, let's say, new attributes, like if I wanted to add an ID, so I was going to make something like an ID equals models dot maybe integer field or whatever. Like if I was to do something like that, I would have to go back and do Python manage.py make migrations again to now generate the new version of this table, and it would increment the migration revision number to say something like 0002. So keep track of what migration revision number you're on. If you forget what migration revision number you're on, you can list them with Python show migrations. So if I do Python okay, it will list them. It'll list a bunch of apps here because there's a lot of the Django middleware going on has different stuff using the database as well. So it's going to list that. Find your app and find the revision number per your app. So here's start here, and here's the revision. Okay, so after we do, so you have to do this in 3 steps. After you do make migrations, then you do migrate. If everything works well, if you don't receive any errors in that step, then you're safe to do Python manage.py migrate. Okay, and everything should be okay. So once again, you should check out if there's any errors, then you're going to want to fix those errors and re-perform these steps before you move on. But if everything is okay, if you apply the migrations, now the final step, keeping track of what revision number we're on per what app we're concerned with. We're going to apply the migrations per that app. So we're going to call Python manage.py SQL migrate whatever app we're migrating at whatever revision number we want to migrate to. So you can note here, if you do want to go back to like an old revision of your database structure, you can do this by specifying an older revision number. But for now, let's just go with the most current one. Okay, and this will actually spit out the SQL code that it's generated. We could just ignore this code. But if you were somebody that like actually knows SQL and you're just you're using Django for the convenience, which is a common thing to do, you might actually want to look this over and be like, did this generate what I think it generated? So you do have that option. And if you look, this might have already been there when you created this project, but if it wasn't there before, it should be here now, this db.sqlite. In this course, we're going to be using SQLite. SQLite is not like a real production database. It's really just used for like prototyping stuff. It's very useful like that. Setting up a real database is a whole process that we're not going to go over for this course. You will inside a later course. For now, let's just work from SQLite. And then most of what we do is going to be transferable over into real databases if you want to set up a real database later. Okay, but for now, we're using SQLite, and basically our entire database is just going to be stored inside of this file, this SQLite 3 file here. Okay, I kind of don't recommend you ever do this, with the exception of maybe when you're first kind of initializing your your project and setting up your database. If you perform a migration like too early and you're like, oh, I don't want to have this like migration with the revision number sitting there that I don't like ever want to use, you can like delete your entire database, kind of like nuke your database with these two steps here. So this, I made this little incantation for you guys if you choose to use it. I kind of like don't like once you get a project going though, I kind of don't recommend you ever do this. Okay, so now you might think, okay, now we've made our database, we have our table, so like there's an actual database that corresponds to this class now. Now we should test out this view. However, what is this view going to try and do? Well, it's going to try and look at all of the entries into the person table right now, and it's going to try and pull out the first one. But we don't even have any entries into our database yet. So there's a few ways we go about adding entries into the database. We could create another view that does this and then go to that view first. But we could do this in a more manual way by using the Python shell. So I've already kind of showed you how to use this shell. This shell is going to be more important now that we're using the database. The shell is going to be very useful. You could enter the shell. It'll give you a Python REPL. Just like any other Python REPL you've been using, but you'll have access to your full Django project in here. So you can import, so you could say like from whatever your app is, .models, you can import whatever class it is that you're using, and you can play around with that class, and you can use it to like manually insert stuff into your database if you want, or you could use it to just like test out different queries before you actually encode them up into a view or something like that if you want. So let's give that a try. So we'll go to the same directory as manage.py, make sure our Django environment is enabled. And let's do Python manage.py shell. And this will open up the shell for us. Okay. Your shell might be a little bit different depending on if you have your default like Python shell set to the interactive Python or just a normal Python shell or whatever, but that's not too important. So from here, we can import our model. So we're going to say from start.models. So this file, this models.py file, okay, I can actually do an ls here. So our project, it has a start folder, and that start has a models.py inside it. So the way Django, Python imports work, you do something like from start.models, so from this file, and then I could import whatever I want from this file, including this person class. Okay, so now I have access to this person class, which corresponds to a person table in my SQL database. So I could do stuff like I could test out, I could say person.objects. Okay, so person.objects is going to return something of type query set objects. Query set, sorry. It's going to return a query set object. And I can call all on it to just kind of list all of the different objects that I have in my database. And I'll explain what this query set is in a moment, but you'll see that it gives a query set empty list. So you can kind of infer from this empty list means, well, there's nothing in my database right now. So what if I want to add something to my database? So there's basically two different ways you go about adding something to your database. So I'll show you the more manual way. So the more manual way is I'll create an instance of the person class. So I'll say new person equals, so just the same way you would create an instance of any class, person, and we'll give it an name, and we'll give it an age. Okay. And this still hasn't added something to the class yet. So if I do person.objects.all again, it's still empty. If I want to actually add this to my database, what I need to do is I need to take this instance and I need to call the save method on it. And this is true too if I look up an object instance from a database and then I make a change to it. If I want that change to sync with the database, you need to call the save method on it. So if I call save now, and now I list all my persons again. Okay, so now I have a query set object that's holding a list with one person object inside of it. And I could test out, like, say, this code here, where if I do person.objects.first, that returns my one person object that's inside my database. Okay, so now I'm at the point where I can, let's say, exit my shell. So I'll use exit method as I exit any Python REPL. And I can run my server, and I'll just run it locally, a localhost 8000. Okay, so now I can try going to this e/macid/start/first_person, and it should return back the first person, which would be a JSON response of Curtis 43. Okay, whoops. So if I go to localhost e/macid/start first person. All right, so I have this view just returns a JSON response, and you'll notice that when I return a JSON response, it'll try and like automatically serialize anything that you give it into a JSON object to return back, which basically means you should be putting it inside of a Python dict, like a dictionary. So if I take a person object, I should convert it into a dictionary, nicely however I want it to be formatted with my key value pairs, and then send that back. And I'm just returning a JSON response, so the page that gets rendered is just, the JSON object that gets returned. Okay, let's talk a little bit about defining these models. So like I mentioned before, all of these models, they're defined as a class that inherits from the model class. So the Django.db.models package is going to provide this model class, and it's going to provide a variety of fields that will serve as the attributes to this class. So there's a variety of different fields. You could refer to the documentation for a full list of field types, but some example ones are going to be like chart field, which you need to get. Chart field is going to hold different strings. When you're working with a database, if you want to hold strings in a database, you're going to need to give it a maximum length of a string. So you can't just be willy-nilly. Here's a database table, and part of it is going to be holding strings. Like one of the fields of this table is going to hold strings, and they might be whatever length. No, you have to tell it what the max length is going to be. An integer field, I already kind of showed you that with age. Float field is another common one you'll use. Boolean field is another common one. Date field is an interesting one. That'll hold the current date. If you use this parameter, then it will automatically insert a date as long as you don't specify when creating the model what the date is. It'll automatically insert a date that is like the current date when it was created. So I recommend checking out the Django documentation on field types to see a full list of different field types. There's quite a different large amount of them. There's a big integer field for holding lots of different like really large integers. There's an email field specifically for holding emails. There's a file field and even an image field if you want to create a site that allows users to, like, let's say, upload images. You'll want to use this image field. There's all sorts of these different fields that you could be referencing. Okay, so I already showed you one way to create insert an entry into your database. Another way we can go about it is a more direct way is to use the create method. So I'll give you another example of this. So if we let's shut our server down. Let's go back to our shell. Okay, and let's import again. So from start.models, import person, and we can do something like person.objects.create, and we need to give it the fields that person takes. So stuff like name equals Jimmy, age equals 22. Whoops, I'm spelling name here. Okay, and you'll see this when I use the create method, I no longer have to do save. It automatically, it just kind of skips a step for us, and that it automatically saves it. And let's create one more person. Let's create person Joe, and his name could also be, or his age could also be 22. Okay, and now that we've created some people, we've populated some entries into our database. Now the next logical step is, well, how do we start retrieving these entries from the database? So I mentioned right away that a database should provide a way of searching, doing a particular search, which we call a query, for different entries inside of that database. So Django provides this object that I've already introduced you to called the query set object. And whenever you do the class.objects and say .all, that will return a query set, which kind of holds a list inside it. If you do first, that'll just return a single object, but there's other methods to do with query set that you're generally going to want to use. One thing to note about query set is it's implemented. It implements iterable, so I could do something. Basically, if anything implements iterable, that means that I could use for in with it. So I could do something like for person and person.objects.all. And I could say print name is. So I could iterate all over the query set that is returned here. And I could return person.name. Okay, so I could iterate, and whenever I return a query set, I can iterate over it, just like I would iterate over, say, a list. I definitely recommend also checking out the documentation on query sets. Well, I'll go over some of these methods right now that return other query sets and how to combine query sets. So you could do stuff like filter, like search for a particular object, and that returns a query set, and then perform another search over that query set. The query sets are meant to be combined together like this, which is why it's not returning, say, just a list like that. Okay, so the first sort of query that we're going to want to probably perform is a get query. Okay, so this is a way of looking up a specific object. So if we want to find a single object that matches a certain criteria, so a single entry, okay, into our table that matches a certain criteria, we use the get method. Now, the get method is going to raise an exception, object does not exist, if it's unable to find this object. So when using the get method, I recommend you always perform it inside of a try except structure. And to do this, you're going to have to import from Django's exceptions the object does not exist exception. So I could take this, and let's create another view here. So I can insert this here, and let's put this import at the top. So make sure we import this object does not exist exception, and let's create a view. So I'm going to go to my urls.py here, and I'm going to create another path that's going to route from get person, and it's going to route to the get underscore person underscore view. It's going to have the name get underscore person. Okay, so let's define that in here. Def get underscore person underscore view. And what I'm actually going to do is I'm going to use I'm going to capture two values from my URL here. I'm going to have a string name, and I'm going to have an int age. Okay, so this will be routed from get underscore person, and it's going to take a name and an age. So this will be a request, and it'll have a name and age parameter because we're using Django's capture syntax to capture these values from the URL. So we have a name and an age, and we're going to be able to use this. So in our case exception here, okay, we're going to be able to use this. We're going to say person.objects.get name equals name, age equals age, and this will be the name and age that were provided by the URL. Okay, and let's say we find that person. We can do the same thing that we did up here and return it inside of a JSON object. Okay, now let's say we don't find that person. So there's a few ways we can handle this. One thing we might want to do is just create that person, insert it into the database, and then just return it anyways, like reiterate it back. And generally, what you're going to want to do when you try and do a lookup from a database and you can't find that resource is you're going to return an HTTP response with a 404 signal for not found, the 404 status code. So to do that, I actually already have this imported from Django.http, this HTTP response not found. So let's get rid of this print, and instead we'll do return HTTP response not found. So we'll return an HTTP response, and we'll include a string saying like, well, I was unable to look up this name and age here. Okay, so let's exit out of our shell and let's run the server again. And let's give that a try. Whoops, did I make an error? Oh, I forgot the colon. Oh, I need one there too. The colon here. I got a little syntax error there. Syntax errors happen to the best of us. Okay, let's run the server. Okay, so now I don't have errors. So now I should be able to go to this URL, and I'm going to give a specific name and age here. And so let's try out something I know that exists to start off with. So I could go to get underscore person Curtis 43, and it returns Curtis 43. Or I can do Jimmy 22. Okay, and it's able to find Jimmy 22. It returned it back in the JSON response. Okay, so now I'm able to like look stuff up. This is how you would look something up, a specific object from a database. Now, what happens if I'm not able to look it up? Let's say I look up Jimmy with the incorrect age of 23. Okay, so now I'm returning an HTTP response. This is a good thing on the technical side of 404. Okay, and I get this response back that I put inside here of failed to look up Jimmy at 23. So something to mention about using the get method. So it's made to return a single object. If the object does not exist, it raises this object does not exist error. So I told you how to deal with this. However, it might also raise another exception if it finds multiple objects. So this is made to only return a single object, and if it finds multiple objects that fit this criteria, then it's also going to raise an exception. And you could handle this in two ways. One would be to add another exception here for multiple objects. So you would just keep chaining this together. Multiple objects, blah, 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 and do whatever you want for that, right? But my general recommendation would be the only time you ever use this get method is when querying on a primary key. So I'll go over what a primary key is in more detail on Friday, but just a little introduction to it. When you create a table with different attributes, you can specify that one of these attributes is a primary key. And this means that every entry is going to be uniquely identified by that key, which means that there can't be two entries that exist with that same attribute. So like, let's say I made name my primary key in the person object. That means that if I were to do a get search, and I wouldn't even have to include the age here, I could just search by the name. I would rest assured that there would only be at most one entries returned. If I try to insert two entries with the same name, the database will give me an error. It won't let me. It would not let me insert another entry with the same primary key like that. So in general, I'd recommend only using this get method if you're querying over the primary key. Okay, so what if you want to query not for a single object, but for all of the entries that will match a certain criteria? So for that, we can use the filter method. So the filter method, it's going to return another query set. So you could take the objects query set and return another query set on top of that. So let's test this out. So let's say we want to define another view. So I'm going to define a view here. We'll call it filter person. And this view will only capture age here. Okay. I'll change this to filter person. Filter person. Okay. So let's make that view now. So this view is def filter underscore person underscore view. That takes request and just an age this time. Okay. And where's this going to get routed from? It's going to get routed from filter person and no name. Okay, so I have this filter person, and what I'm going to do is I'm going to look up, I'll call it people because it's going to be a query set of these persons objects. It's going to be multiple persons. Person.objects. Get, or sorry, filter now, and I'll specify age is equal to, let's find all of the ages that match to age here. Okay. And now I can do something like, let's say I want to return a JSON object with a list of all of the people of this age. So I would do something like this. I would make a key names here, maybe empty list. And then I can iterate over people. So I could say for person and people, JSON names, append, and I'll append to this list here. Person.name. Okay, so this will make a list. And then I could also just this code, return a JSON object here. Okay, so this is going to return all of the people, the names of all of the people that match this, that match whatever age I'm giving it. So let's give that a try. So is my server running? Yep. So I'll save. I'll make sure everything is saved. Looks like I got no errors. So let's go here. So it's going to be filter underscore person. Let's find everybody with age 22. Okay, and I have two people with age 22, Jimmy and Joe. Now, a similar method is the exclude method. So the exclude method, so this is actually like not the similar, but the co method, you call it, is the opposite. It'll find everything that doesn't match this criteria. Okay, and I mentioned before that like filter, it operates on query sets and it returns a query set. So you could use methods that are like this, that operate on query sets and return query sets as combinators, combining them together. So for example, I could do something like, let's filter for everybody that matches a certain age, but let's exclude Jimmy. Okay, we don't care about Jimmy. We'll exclude him. So now if I go back to my example here, See, now it just returns Joe as 22 because I've excluded Jimmy in this example. Okay, so there's many more ways to combine query sets like this. The whole point of having of returning a query set of objects and not just, say, a list of objects is that it comes with a variety of combinators you could use to combine and do more complicated searches of your data. And we'll be going them over more on Friday. And along with that, we'll have to tackle the scary concept of relational algebra. Ooh. Okay, so see you guys then.